For a mobile home service, a ground rod is required at the main disconnect. Additionally, a ground rod is also required at the mobile home itself. This dual grounding approach ensures a robust and safe electrical system. The purpose of a grounding electrode system, which includes ground rods, is to provide a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices like circuit breakers or fuses. This helps to minimize the risk of electrical shock and fire hazards. At the main disconnect, typically located where the service conductors enter the property, the ground rod serves as the primary grounding electrode. It is connected to the grounding bus within the disconnect enclosure, which is bonded to the neutral conductor, effectively creating a grounded system. This initial grounding point is crucial for establishing a reference point for voltage and providing a path for fault current originating from the utility side of the service. The requirement for a second ground rod at the mobile home itself stems from the fact that the mobile home is considered a separate structure. The electrical system within the mobile home needs its own grounding electrode system to ensure that any faults originating within the mobile home have a direct and effective path to ground. This is particularly important because the connection between the main disconnect and the mobile home is often made via a feeder cable, which, while containing grounding conductors, may not provide as low an impedance path as a dedicated ground rod. The ground rod at the mobile home is typically installed as close as practical to the mobile home's electrical panel. It is then connected to the grounding bus within the panel, which is also bonded to the metal frame of the mobile home, ensuring that all metallic parts are at the same ground potential. This bonding is critical for preventing voltage differences that could create shock hazards. The installation of ground rods should adhere to the National Electrical Code or NEC and local electrical codes. The NEC specifies requirements for the size and type of ground rods, as well as the methods for their installation. Typically, ground rods are made of copper or copper-clad steel and must be at least 8 feet long. They should be driven into the ground to their full length, ensuring good contact with the soil. In areas with rocky soil, it may be necessary to bury the ground rod horizontally in a trench. The connection between the ground rod and the grounding conductor must be made with approved connectors or clamps designed for direct burial. These connectors should be corrosion resistant and suitable for the materials being joined. The grounding conductor should be sized according to NEC Table 250.66 based on the size of the service entrance conductors. It is important to ensure that the grounding conductor is properly protected from physical damage. If it is exposed, it should be run in conduit or otherwise protected. The resistance of the grounding electrode system should be tested to ensure that it meets the requirements of the NEC. Ideally, the resistance should be 25 ohms or less. If the resistance is higher than 25 ohms, an additional ground rod may be required. The NEC specifies that if a single ground rod does not achieve the required resistance, a second ground rod should be installed at least 6 feet away from the first. The two ground rods are then connected together with a bonding jumper. In addition to the ground rods, the metal water pipe system can also be used as a grounding electrode, provided that it meets certain requirements. The water pipe must be in direct contact with the earth for at least 10 feet, and it must be electrically continuous. A bonding jumper must be installed around any insulated joints or meters in the water pipe. If the metal water pipe is used as a grounding electrode, it must be supplemented by an additional grounding electrode, such as a ground rod. This ensures that there is always a reliable path to ground, even if the water pipe is disconnected or becomes non-conductive. The NEC also requires that the grounding electrode system be bonded to the building's metal frame, if any. This bonding helps to ensure that all metallic parts of the building are at the same ground potential, reducing the risk of electrical shock. The bonding conductor should be sized according to NEC Table 250.66, based on the size of the service entrance conductors. It is important to note that the grounding electrode system is not intended to carry current under normal conditions. Its primary purpose is to provide a path for fault current to return to the source. However, in the event of a ground fault, the grounding electrode system will carry a large amount of current, so it is important to ensure that it is properly installed and maintained. Regular inspections of the grounding electrode system are recommended to ensure that it is in good condition and that all connections are tight and corrosion-free. Any damaged or corroded component should be replaced immediately. It is also important to ensure that the ground rods are still properly driven into the ground and that they have not been pulled out or damaged by frost heave. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for specific recommendations regarding the grounding of mobile homes or any other electrical system. Compliance with the NEC and local electrical codes is essential for ensuring electrical safety and preventing electrical hazards. Failure to properly ground a mobile home can result in serious injury or death. In summary, the requirement for a ground rod at both the main disconnect and the mobile home ensures that there are two independent grounding electrode systems, providing a redundant and reliable path for fault current to return to the source. This dual grounding approach is critical for protecting occupants from electrical shock and preventing electrical fires. Proper installation and maintenance of the grounding electrode system are essential for ensuring its effectiveness. Always consult with a qualified electrician to ensure that the grounding system is installed in accordance with the NEC and local electrical codes. Firstly, the ground rod at the main disconnect provides the initial grounding point for the entire electrical service. Secondly, the ground rod at the mobile home ensures that the electrical system within the mobile home has its own dedicated grounding electrode. Thirdly, this dual grounding approach provides a redundant path for fault current to return to the source. Fourthly, proper installation and maintenance of the grounding electrode system are essential for ensuring its effectiveness. Fifthly, always consult with a qualified electrician to ensure that the grounding system is installed in accordance with the NEC and local electrical codes. Understanding the purpose and requirements of grounding electrode systems is crucial for ensuring electrical safety in mobile homes and other structures. By following the guidelines outlined in the NEC and consulting with qualified professionals, it is possible to create a safe and reliable electrical system that protects occupants from electrical hazards. Remember that electrical work can be dangerous, and it should only be performed by qualified individuals who are familiar with the NEC and local electrical codes. If you are not comfortable working with electricity, always hire a licensed electrician to perform the work. The cost of hiring a qualified electrician is a small price to pay for the peace of mind that comes with knowing that your electrical system is safe and properly grounded. In addition to the ground rods, other grounding electrodes that may be used include metal underground water pipes, metal frames of buildings or structures, and concrete encased electrodes. Each of these electrodes has its own specific requirements for installation and connection. The NEC provides detailed guidelines for the use of each type of grounding electrode. It is important to choose the appropriate grounding electrode for the specific application and to install it in accordance with the NEC. The effectiveness of the grounding electrode system depends on several factors, including the type of soil, the moisture content of the soil, and the depth of the ground rod. Sandy soil, for example, has a higher resistance than clay soil, so it may be necessary to install additional ground rods to achieve the required resistance. The moisture content of the soil also affects its resistance. Dry soil has a higher resistance than wet soil, so it is important to ensure that the ground rods are installed in an area that is not likely to dry out. The depth of the ground rod also affects its resistance. The deeper the ground rod is driven, the lower its resistance will be. For this reason, the NEC requires that ground rods be at least 8 feet long. In some cases, it may be necessary to drive the ground rod even deeper to achieve the required resistance. When installing ground rods, it is important to avoid underground utilities such as gas lines, water lines, and electrical cables. Before driving a ground rod, it is always a good idea to call the local utility companies to have them mark the location of any underground utilities. This will help to prevent damage to the utilities and ensure the safety of the installer. The grounding electrode system is an essential part of any electrical system. It provides a path for fault current to return to the source, protecting occupants from electrical shock and preventing electrical fires. Proper installation and maintenance of the grounding electrode system are essential for ensuring its effectiveness. Always consult with a qualified electrician to ensure that the grounding system is installed in accordance with the NEC and local electrical codes. Grounding is not the same as bonding, although the terms are often used interchangeably. Grounding refers to the connection of the electrical system to the earth. Bonding refers to the connection of metallic parts of the electrical system to each other. The purpose of bonding is to create a low impedance path for fault current to flow, allowing the overcurrent protective devices to operate quickly and safely. All metallic parts of the electrical system, including conduit, enclosures, and equipment, should be bonded together. The bonding conductors should be sized according to NEC Table 250.122, based on the size of the overcurrent protective device. It is important to ensure that all bonding connections are tight and corrosion-free. Loose or corroded connections can increase the impedance of the bonding path, reducing its effectiveness. Grounding and bonding work together to provide a safe and reliable electrical system. Grounding provides a path for fault current to return to the source, while bonding ensures that all metallic parts of the electrical system are at the same potential. Together, they help to protect occupants from electrical shock and prevent electrical fires. Remember to always consult with a qualified electrician to ensure that your electrical system is properly grounded and bonded. Mobile homes often have unique electrical requirements compared to traditional site-built homes. These differences stem from the fact that mobile homes are manufactured in a factory and then transported to their final location. As a result, the electrical system must be designed to withstand the stresses of transportation and installation. One of the key differences is the way that the electrical system is grounded. In a traditional site-built home, the grounding electrode system is typically connected to the building's foundation. However, mobile homes do not have a permanent foundation, so the grounding electrode system must be installed separately. As discussed earlier, this typically involves the use of ground rods. Another difference is the way that the electrical system is connected to the utility service. In a traditional site-built home, the service entrance conductors are typically run directly from the utility pole to the built-in service panel. However, mobile homes are often connected to the utility service via a feeder cable. The feeder cable runs from the main disconnect to the mobile home service panel. The size of the feeder cable must be sufficient to carry the load of the mobile home's electrical system. The NEC provides guidelines for sizing feeder cables. Mobile homes also have specific requirements for the location of electrical outlets and switches. The NEC specifies that electrical outlets and switches must be installed in accessible locations and must be protected from physical damage. In addition, mobile homes must have ground fault circuit interrupter or GFCI protection in certain locations, such as bathrooms and kitchens. GFCI protection helps to prevent electrical shock by detecting ground faults and interrupting the circuit. Mobile homes are subject to the same electrical codes and standards as traditional site-built homes. However, there are some unique requirements that must be considered. Always consult with a qualified electrician to ensure that your mobile home's electrical system is installed in accordance with the NEC and local electrical codes. Proper grounding is essential for protecting yourself and your family from electrical shock and preventing electrical fires. Make sure that your mobile home's electrical system is properly grounded and bonded, and that all electrical outlets and switches are installed in safe and accessible locations. If you have any questions about your mobile home's electrical system, consult with a qualified electrician. They can help you to ensure that your electrical system is safe and up to code. Electrical safety is everyone's responsibility. By taking the time to learn about electrical safety and following the guidelines outlined in the NEC, you can help to protect yourself and your family from electrical hazards. Remember, when in doubt, always consult with a qualified electrician.